11.7 Surface areas and volumes of cones. Essential question: how can you find the surface area and the volume of a cone? Let's take a look at the surface area. It has a formula that goes like this: S is equal to pi r squared plus pi rl. Now the pi r squared comes from the base. Here's the base right here. And so this part right here is really the what we call the lateral area. It has this kind of a shape, which is part of a big circle. Let's go ahead and take a look at how we find that area. Really, this part right here that is making the cone right here is proportional to the big circle that it's part of. So we say that the lateral area, this right here that makes the cone, is in a ratio to the area of the big circle right here, and the arc length right here will be in that same ratio to the circumference. So area to area, arc length to circumference. So we have lateral area, which is what we're looking for, a formula for that. And this radius of the big circle has an S, so it's pi s squared. And the circumference of the cone has a radius of r, and it only takes part of the circumference of the big circle. So we write 2 pi r. Now the circumference of the big circle has a radius of s, so we write 2 pi s. Now we have this nice proportion. What we can do is we can reduce, and then I'm going to cross multiply, and when I do that I'm going to get one of the s's to reduce, and then I'm going to get pi r s, where s represents this slant height. It represents the radius of the big circle. Now in mathematics we a lot of times call this SL for slant height. So I'm going to take this S and I'm going to write L. And let's go back to our notes, and here's our notes again, and maybe this makes a little bit more sense now. Pi r l. Here's our L right here. Okay, so let's go ahead and find the surface area. We write out the formula, and remember this represents the slant height, so that's what I put in here. My radius is pretty evident, and this is the exact answer, and if they ask you to do some rounding, you go to the next step. Otherwise, if it's an exact answer, you can just leave it this way. Okay, your turn. Go ahead and stop the screencast and see what you can do. And here is the answer. Now let's explore volume. Now we did something similar to this with pyramids and prisms, and so now we're going to do something similar with cones and cylinders. And again, this is both of these have the same area of the base, and both of them have the same height. And you can see again, just like we had before, it's going to take 3 full cones to fill up the cylinder right here. And so the formula is going to be very much the same as the formula for a pyramid. 1/3 area of the base times the height. But the base is always the same, which is pi r squared. Okay, here's how we do the problem. 1/3 area of the base times the height. We just figure out the area of the base, and I put it in red. Here's my height. Remember Cavalari's principle. This volume will have the same volume as the volume of one that's standing straight up, as long as the cross sections and the heights are the same. Your turn. Stop the screencast and see what you can do. And here's the answer. All right, let's look at similarity. These two cones are similar, and we'd like to figure out the volume of cone B. So I set up my proportion here. Volume of the large, I know the volume of the small one is 15 pi. I know the scale factor is 9 to 3, which is just 3. When you take 3 and square it, it's going to be 27, and my answer will be 405 pi. I'm going to leave it at 405 pi because the volume of the small was in terms of pi as well, so that will be fine. Okay, your turn. Stop the screencast and see what you can do. And here's the answer. You could have very well just stopped right here because the volume of the large was in terms of pi. You can leave the volume of the small in terms of pi as well. What about composite solids? This is made up of a cylinder and a cone, so I'm going to get to use both of those formulas. They both have the same area of the base, so that's nice. And then here's my exact answer, and here's my approximation. Your turn. Stop the screencast and see what you can do. And here is the answer.